Hey everybody, we're going to go over series parallel and series parallel circuits. I'm going to try to simplify as much as possible because it makes it easier for me too. So I'm going to try to give you my way of doing it, and we'll give you some formulas that you can do it a different way also. On series circuits, it's anytime you have two or more in a kind of a series. If it's just one, it's actually a simple circuit, which is pretty much close to a series, but it could also be a parallel. But if you look at this one, it goes through one bulb to another, one bulb to another, but back to ground. Any one of these bulbs that actually burns out will actually affect the other two bulbs. This is one of the downsides of a series circuit. Ohm's Law, we talked about Ohm's Law before when we talked about how Ohm's Law affects the current. And we can, if we have two values, like maybe we know the amperage and we know the resistance, then we can figure out the actual the voltage and the resistance. We can figure out how much amperage flow is going through it. So this is what we need to think about when we're thinking about basic kinds of current flow or voltage. This is an example again showing you the whole circuit, actually three bulbs in it. These are three bulbs, all current flows through them equally. So if I wanted to figure out what kind of amperage is flowing through, I know what the resistance is, I know what the voltage is. If I add the resistance together, so I got 3, 2, and 1, that's 6. So if I divide the 6 into the 12, I got 2 amps of current flow going on. If I go to my 2-bulb circuit, same applies. If I take my 1 if I take my 1 ohm of resistance and my 2 ohm of resistance, I add them together, then I can actually figure out what my 12 volt battery current flow would be. So I would actually have, divide 3 into 12, I have 4 amps of current flow going on. Kirchhoff has his second law. The voltage around any closed circuit is equal to the sum or the total of the voltage drops across resistance. So what he's talking about, we should have a complete voltage drop. So all the voltage should be used up by the ground. Okay, so if I have anything that's kind of reflecting back for whatever reason, I know I have a resistance problem or a connection problem going on. So my 12-volt battery has to go through this wire, through my fuse, which my fuse should be pretty much not interfering with any of the current flow going through it. Okay, so any voltage should be able to go through to the actual bulb itself. And then my bulb should drop all that voltage. In other words, use up all that voltage. If it doesn't, then we got some kind of problem going on, either on the voltage side, or we actually have a problem on the ground side. Normally, I would look at the ground first, but still, you could have it on either side. Maybe that fuse did have a bit of resistance on it too. It happens, believe me. So if I were to take my voltmeter and go from here to here, I should see no drop. I should see close to 0, or I could just take and go boom, boom, and then look at the beginning, boom. And then if I went to my positive this side, I would see 0. But it's better to do voltage drops, and that's where you take the meter and you go across each little section. And that's going to be a better way of figuring out that actual problem. Usually it's a resistance, it's going to be a resistance in that circuit. And one of the biggest ones I found in the field was the ground side. Sometimes grounds come loose. Sometimes they get corroded from either whatever reason. They could be being on the road that cause them to corrode a little bit. They're not wrapped correctly. They can be corroded also. This is a 2-bulb circuit, and well, 3-bulb circuit, I'm sorry. And this one actually shows where you can actually figure out the drop across. So I know all of my bulbs here. Okay, I know my resistance, so I got 2, 6, and another 6. So if I divide that into 12, I know I got 1 amp of flow going on. I got 1 amp going through all these different bulbs. If I have my 2 bulb circuit or my 2 resistors on this particular one, this is a resistor symbol, and I know I have 2 ohms of resistance and 4 ohms of resistance, I can add this together, okay? And I end up with 6, and then I've divided into the 12, I end up with 2, 2 volt, really 2 amps or 2, I can actually figure out the voltage drop. If I go 2 and multiply it by the 4, then I'm going to have an 8 volt drop. If I multiply this by 2, then I'm going to have a 4 volt drop. It's pretty quick and simple. Series circuit laws, there's a few different laws that are in effect. The current resistance in a series circuit is the sum of all the total, all the individuals. So like we've been doing, we've been adding them up. And then the current in it is constant throughout the entire circuit. In other words, that 2 amps is going all the way through, like I said before. And then although the current is constant, the voltage drops across each resistor in the current circuit. The voltage drop across each load is proportional to the value of the resistance compared to the total resistance. In other words, we're just taking and even though we have current actually flowing evenly across the whole circuit, we can calculate what the voltage drop should be. Now, please understand that when resistors or bulbs start to warm up, the resistance increases. So that's what we need to keep in mind. So these are just a prediction. We should have it somewhere close to, okay? And this is just showing you an example of how we would do a voltage drop. And this particular circuit, I have a voltmeter, and I'm going through and checking to see where my voltage drop is. Okay, this is just showing a voltage drop. All right, so this one actually has 1 resistor we don't know the value of, but we do know it has a 12 volt battery. And we do know it has 3 amps of current flow. And we can calculate and figure out what that other resistor is. If we look at it, and I use my formula because we know that it's 3 amps going through the whole circuit, then I must be able to really quickly figure out what that second resistor is. So if I take that 3 and divide it into the 12, so I take my 3 ohm resistor and resistor 1 and then divide it into 12, I end up with 4. Okay, so that should be 4. So I need to have 1 more resistor. Remember, we got to add them up. So if I have 1 more resistor, I have to have 1 more ohm of resistance, and that will give me that 4. So my resistor 2 is 1 ohm of resistance. Now, in your parallel circuits, we treat them differently. We use a lot of parallel circuits for things that we want to make sure they have power and ground to. And one of the good examples I can give you is your headlights. You don't want both headlights to go out, so we don't put them in a series circuit. We put them in a parallel circuit. And if there's a problem with one of the bulbs burning out, the other bulb will actually glow. And that's what happens in a parallel circuit. If we have a good connection on my ground and also on my power source to the bulb, then we're going to be okay. We're going to actually be its own little simple circuit together, and it's getting fed a certain amount of current through that particular bulb. Here's a good example of current flow. Now, if I look at it, I have one bulb that's at 6 ohms, and I got another one at 3 ohms. And I know if I drop my one bulb, so I have my 12 volt battery, and I have 3 ohms of resistance, I need to drop 4 amp. I need to have current flow of 4 amps to make it go. So if I take my other bulb, I know I have to have 2 amps. So that's where those two, if you add them together, we should have a total of 6 amps of actual current available. Okay, I can't have 4, or else it wouldn't have enough for the second bulb. And this is just showing, again, kind of a simplistic way of looking at an actual a parallel circuit. If you were looking at a diagram, you might see something like this, or maybe they substitute in the bulb instead of the resistor symbol when they start mapping everything out. So this is just trying to show you the different types of symbols, because we're going to get deeper into, when we get into wiring diagrams, of other symbols as we go along. Now on another diagram here, kind of showing you it again, I have 6 amps going through. Remember, that was almost like looking at the other diagram I had a little bit earlier. So this is kind of simplistically putting it for you. All right. Now, I have another part that we're going to be talking about, and this is going to be about the series and parallel circuits. Now, series parallel circuits are what I call combination circuits. And depending on what where it's at is how we actually treat it. A lot of times what I like to do is take a series parallel circuit and kind of simplify it across. And I'm going to try to help simplify it for you. So this is an example of a series parallel circuit, but we have a resistor at the front end. And what I like to do is simplify it for myself. So I know that it's going to drop across that first resistor. And what I do is I take that 2 ohms of resistance and I divide it into the 2 volts. I mean, 12 volts, that 12 volt battery. And I know now it is 6. You know, I'm sorry, I'm getting confused myself here. If I divide it in, I'm going to end up with what? Okay, so I'm going to end up with 6. Okay, total. So if I need to find out what the total amount is going across, I need to do some more calculations. Okay, so if I look at the first part, okay, and I look at the first part and I look at it, I take that first resistor and I take it and divide it into the 12, and I end up with 6. Okay, so I know it's going to drop that. Well, it's going to have 6 volts available on that first resistor. So that would be 1 amp it'd have to take care of. So this guy right here, okay, is going to drop it down to 6. Instead of being a 6 volts, I'm going to drop it down to actually 6 volts. Go across here, I have 1 amp going here. But that 6 going across here, okay, is going to make it 2 amps. So the total ampere flow would be 3 amps. So try to uncomplicate it again. I always take and divide, if it's a resistor in the front, I always take it and divide it into the power source. So my 12 volts into my 2 ohms into my power source is going to give me 6. And then I have to drop it across the first resistor. I have to have enough current flow across that. So 6 and 6 and 6 is 1. And then I know I'm going to have to drop across the other one. So that 3, okay, is going to go into the, actually 6 and equals 2. So I know I have 3 amps of total current flow. I hope I didn't confuse you too much. But when you're talking about using multiple resistors in a one parallel leg or series parallel, then this is kind of simpler to do. Again, they still consider this as for a series parallel because you're adding more into it. So the way to solve this one is to actually add up that one resistor leg. So here is an 8 ohm over here on my resistor 3. I just add these 2 together and make it another leg of 8 ohms, kind of simplify it. So I take that and I divide it into my 12 volts and I end up with a amp and a half. And then I can do that on my second leg. Divide the 8 into 12 and I get an amp and a half. So now I have 3 amps of total flow. I hope this was beneficial and it made it a little less confusing. If you really like this kind of stuff, math and all, which I do, in math and science, that's what I really, really like. So if you really like this, please like and subscribe. And if you have any other simpler ways of doing it, let me know. And I will definitely look at your comment down below, and I will actually go ahead and possibly do another video, and I'll give you credit for your way of doing things too. I know there's a lot of calculators out there that you can actually use too. You can go online and there's some calculators you can actually put your resistances in, and then you can actually tell what voltage it is, and it'll give you the amperage flow and all that too. So it really does, help you out. You can put it calculator right on your phone to figure that out too. There's so many other ways of doing it. All right. Again, like and subscribe, and definitely, please, I would really appreciate it. Take care now, and until next time, bye for now.